Welcome to the class. So today's topic is ring formation reactions. So Paulson-Khand reaction is one reaction that is having the ring closure mechanisms. So the transition metal cobalt catalyzed with the catalyzer 2 to 1 cycloaddition. 2 plus 2 plus 1 means 2 to 1 cycloaddition of alkenes, and carbon monoxide is called as Pauson-Khand reaction. Pauson, Pausan, Pauson-Khand reaction. So it is an inter it is a inter and intramolecular reaction. Means cyclization will done intermolecular and intramolecular. So terminal and internal alkynes will undergo this reaction. Okay, right. Internal alkynes gives low yields compared with terminal alkynes. Alkynes with strongly electron withdrawing groups reduces the rate of reaction. So this reaction is regioselective with respect to alkenes. So based on the different types of substitutions on alkene, so reaction rate or regioselectivity will be there, right? So this is the reaction. This is the alkyne group, and this is the alkene group, and this is the carbon monoxide in presence of cobalt, right? So this is the substitution. So cycloaddition of 2 to 1. Okay. So this is substituted, highly substituted one alkene, and this is alkyne R1, R2, R3, R4, R5, R6 are substituted on alkenes, right? So how the mechanism? There is not that much important, I think, mechanism. This is a cycloaddition, right? Some other time I will explain this one, right? So these are the examples. So this is the alkyne, this is the alkene in presence of carbon monoxide. Cyclization has been done, right? C3H7, C3H7. So this particular part will be of this one color, and another one ours is, so this is another part, right? And this is the carbon monoxide part, right? So this is carbon monoxide, this one. So C2C2 2 to 1 cycloaddition, right? So here also you can see this is unsymmetrical one, the previous one is symmetrical ones. So this is if it is a symmetrical one what, and this is unsymmetrical. This is a trans pH phenyl groups are available. So automatically the substitution also means the after reaction also these two in opposite directions. One is above the plane and the one is below the plane, right? And the another reaction is Nazarov cyclization. So it is a ring closure of divinyl ketones, means doubly alpha beta unsaturated ketones to give alpha beta unsaturated cyclopentanones in the presence of Lewis acid or Bronsted acid. So why at alpha position increases the rate of reaction. So this one. So doubly alpha beta unsaturated ketone with the Lewis acid, alpha beta unsaturated cyclopentanones will form. So here you can see the cyclization. So these two double bonds alternate. These two double bonds are there. So one will be moved towards to the ring closure mechanism. So cyclization in presence of DCM and aluminum chloride LCl3, right? So this is the mechanism how it goes. So the ketonic oxygen will get the positive charge with attachment of means interaction with hydrogen, and automatically the carbon attached to the oxygen attached to carbon will bear the positive charge. So for this positive charge, the double bond of adjacent will move towards to the carbon attached to the oxygen. So automatically the center which is having the alkyl group substituted that alkene position, so that carbon will bear the positive charge. So to satisfy that, the adjacent another carbon double bond CC double bond is there, so that will come in between the positive charge and previously double bonded position. So here it is there. So like this, the center will move and the bond, the carbon carbon single bond will form, right? So this is the mechanism, and these are the some of the examples of this. So how the bonds are formed, right? If it is a biphenyl groups, so then also if it is another one, then also, right? So these are the some of the mechanism. This is the mechanism how it was changed. You can easily identify from where to where it is moving. So oxygen will bear the FeCl3. So iron it will interact. So automatically the oxygen attached carbon will get the positive charge. Then automatically reaction will start, and other double bond will interact with the positive centered carbon to form a CC bond, right? The next one topic is click chemistry. So click chemistry, the reaction between terminal alkyne and alkyl azides in presence of copper sulfate and sodium ascorbate in tertiary butanol to yield 1,4 isomers of triazoles. So this reaction is known as click reaction. So click reaction means the reaction between terminal alkynes and alkyl azide in presence of copper sulfate and sodium ascorbate in tertiary butanol. In tertiary butanol to yield 1,4 isomer of triazoles, right? So this reaction is known as this one. So terminal alkynes and alkyl azides in presence of copper sulfate and sodium ascorbate, right? And tertiary butanol. So you will get 1,4 isomer of 1,2,3 triazoles, right? So the click term referred to facile, efficient and selective and versatile chemical transformation which leads to single product. So in click reaction means previously we have seen one component, means one pot synthesis. In that one pot synthesis, what we have done, so we have charged means we have used at a time all the reagents pouring into the RBF and we have started the reaction. So there you don't get any byproducts. So you will get single product there with combination of all the reagents. So here also you will get a single product without any byproducts. And sub reaction is also efficient one and selective one. So only the terminal alkynes in your reaction reagent. So that will react with azides to form the triazoles, right? So that's why it's called as a click reaction. So the click term referred to facile and efficient and selective and versatile chemical transformation which leads to a single product. So what are the advantages? So highly regioselective, leading to only 1,4 di-substituted products only. Temperature is 0 to 160. So based on the reaction conditions and reaction reagents, you have to use the temperature or you have to go with normal room temperature. Sometimes you have to reduce the temperature also, right? So this reaction takes place without any effect of other functional groups. So reaction in between alkynes and terminal azides only without disturbing any other functional group, right? Here you can see the alkyne, and here it is a R1C triple bond CH, and here you have the R2N3. So in presence of copper sulfate and sodium ascorbate and tertiary butanol, this 1,4 and Y15 isomers are formed because this is a terminal alkyne. So here you can see the mechanism, two copper lithiums, right? So like this it will be separated and copper will interact with the triple bonded carbon. CC triple bond is available now. So this electrons will be interacted or attracted towards to metal copper. So automatically it forms a interaction with this and it will form a bond, partial bond. So automatically the terminal azides are there, N2, R2, N, N, N. So this azidic positions will interact with this triple bonded carbon, one of the triple bonded carbon, because one of the triple bonded carbon is interacted with the copper, because the triple bonded electrons or carbon will interact with the copper. So automatically another carbon will interact the other side of the carbon triple bonded carbon will interact to the nitrogen of azide. So automatically cyclization will take place. So like this, it will generate. So after completion of this, the nitrogen lone pair of electrons will interact or attract towards to the carbon positive center to form the cyclization product like this. So after completion of cyclization, so automatically this copper, whatever the reagent is there, reagent will be removed or eliminated as it is to get automatically 1,4 disubstituted 1,2,3 triazoles. Here you can see two type of isomers are there. So 1,5 isomer, 1,4 isomer. Because based on the reaction condition, this isomers will form, right? So some of these examples here you can see, this is the bromine reaction within presence of azide. So automatically bromine is eliminated, azide is substituted triple N, right? N3 is substituted. So this azidic group will interact with this PHC triple bond C in presence of copper sulfate and sodium ascorbate. Tertiary butanol will be the solvent, right? So like this you will get a product. Same thing here also you can see. So first you have this and you have to convert this last aldehyde group to a terminal alkene. Then afterwards you are using PHN3, this azidic group, and you are substituting on this terminal alkene with an azidic group, right? So here this one also you can see here. So here you can remove one OH group, right? So here you can remove the one OH group. So you will get this OH with a terminal group, means here bromine will react with oxygen area. So automatically HBr will be eliminated. So after HBr elimination, hydrogen bromide elimination, so this triple bond as alkyne group will be attached here on oxygen, terminal oxygen position on this. So after this, the acidic will be there. So on this terminal alkyne position, this azide will be react. Okay. Next, olefinic or olefine metathesis. So mutual transfer or exchange of groups between two different olefinic partners is called as olefin metathesis. Olefin metathesis means the mutual transfer or exchange of groups between two different olefinic partners. Two different olefinic partners means in between two olefins, the exchange or transfer, mutual exchange or transfer of the functional groups. So that is called olefin metathesis. So here we use the Grubbs catalyst. So Robert H. Grubb. So he is one of the scientists who identified or who developed this catalyst. So Grubbs catalyst is also known as a transition metal carbene catalyst. This one is known as transition metal carbene catalyst. So in this catalyst, a transition metal is ruthenium, right? In this catalyst, the transition metal is ruthenium. So compulsory, we require some metal atoms to transition purpose or catalyst purpose. So whenever we are using catalyst, so compulsory there should be a single metal, or previously we have seen the metal pairs also. Sometimes we have to go with metal pairs. Here, metal ruthenium. So it tolerates all other functional groups in alkene, right? So there are two generations of catalysts. So different types of methods are available to generate a catalyst in reaction, right? So first generation of Grubbs reaction and second generation of Grubbs reaction means that it's a catalyst. So this is the first generation of Grubbs catalyst. So very simple one. So this is a benzylidene base tricyclohexyl phosphino dichlororuthenium, right? So this is a structure, you have to remember this whenever you are going for exam. So this is the catalyst. So ruthenium is the center, and phosphorus are there, and chlorines are there, and another one is this benzylidene structure is there, PHC double bond, C double bond. This is a benzylidene in alkene structure. So this is a metal complex, right? And this is the second generation Grubbs catalyst. So this is a bigger one to get more efficient of catalyst purpose. So this is the bigger one structure. Yeah, everything is same, but except one, this tricyclophosphine is removed with another moiety. All right. So Grubb's second generation catalyst is generation, but highly reactive. According to the previous first generation react. That's why I have told you that catalyst will be first generation, second generation means based on the capacity of the catalyzation. So we have to increase the catalyzation. So that's why they changed the some of the moieties to get more reactive nature in a catalyst, right? So this catalyst is sensitive to oxygen and water, so therefore reaction can be carried out in presence of nitrogen, in presence of nitrogen gas, right? Grubbs catalyst is used in organic synthesis to achieve olefins. So olefin cross-coupling metathesis, ring opening metathesis, different types of metathesis are available. There is olefin cross-coupling and ring opening, ring closure. So OCM, ROM, RCM. So sometimes you will get as a question, explain about OCM or ROM or RCM. So you have to remember what is OCM, what is ROM, what is RCM. All right. So these are the examples of OCM. OCM means olefin cross coupling metathesis. Cross coupling metathesis means, so these two olefins are there. So these two double bonded alkenes will react to form a single product. So that is called olefin cross coupling. So you are coupling two alkene groups into a single product here. So that's why it is a OCM, olefin cross coupling metathesis. And another one is ring opening metathesis. So already here you have the double bonded ring. So this ring is opening. So this is called ring opening metathesis. Another one is ring closing, right? Here the first ROM, in ROM you will have seen the ring exposure, ring opening, and here you can see ring closing, right? So olefin cross coupling. Here this is the example. Catalyst is used, the ruthenium catalyst, right? So the trans alkylation of two terminal alkenes under release of ethane catalyzed by ruthenium catalyst, that is Grubbs catalyst, right? Statistically, the reaction can lead to three possible pairs of geometric isomers, that is Z pair for two homocouplings and the cross coupling, right? So total 6 products. So these are the different types, right? So you can get R1 R1 or RR R1. So different types of cross couplings will be possible. So trans alkylation. Exchange of substituent between different olefins is called trans alkylation. So different olefins, right? Here you can see, here both alkenes are there, R1 R1 substituted, R2 R2 substituted. But after reaction, the trans alkylation, so R1 moves from one position to another position, R1 to R2, R2 to R1. So now you get R1 R2, R1 R2. So two different types of products, means this is the trans alkyl exchange of substituents, right? So this is the cross coupling reaction, means cross coupling mechanism metathesis. So how it is exchanging themselves, right, from one position to another position. Yeah, you can see easily 2 plus 2 addition, cyclo addition, 2 plus 2 cyclo addition. So after addition, it will break again. It's a metallocyclobutane complex. It will generate and it will break this one. Again, you will get a product. Okay. Next, this is the ring closing metathesis, right? So ring closing metathesis is intramolecular olefinic metathesis with a Grubbs catalyst yielding the alkenes, right? So here terminal alkenes are there. So in presence of catalyst, ring closing will be done. Means cyclization will be done. Ring closing means cyclization. Here is a mechanism. Okay, you can see this. So how this first is done, right? A ring opening mechanism. So ring opening metathesis is ROM, means ROM is a process of one more cyclic olefin transformation to open chain olefins. So here you have the only one double bond with the ring closure method. So after ROM catalysis, you will get a two olefins, means two double bonded positions, alkenes you will get, right? So nothing but ROM forward reaction is RCM's backward reaction. You can see here this product converts to this, and here this product converts to this. So both are same. So forward direction is RCM, backward direction is ROM, right? So till now today I'll complete here only.